Okay, let's look at some examples of working with numbers in C#. We're going to look at multiplication, addition, subtraction, division, all that good stuff. So let's get going. So let's have a look at an addition example, so how we add numbers in C#. We have a sample application here. We're just defining a variable, setting it to 0, and outputting it to the screen. So not really much is going on here. So we're going to use our variable. I'm just going to do 5 plus 4, which we know equals 9. So I'm just going to run the program, and we get 9 as the output there. So addition is very simple, and you can keep going with this, etc. So very easy. Same again with subtraction. We can pretty much do the same thing. So 5 minus 6 is -1. And you can see subtraction also very easy. And again, you can do this, mix them both. It doesn't really matter. It will work this out for you. So multiplication. Let's do 3 multiplied by 4. To multiply numbers in C#, use this asterisk here, the little star, and we should get 12 as a result there. And again, we can combine multiplication with addition and subtraction, just like you do in mathematics, for example. Now, division, this is where there's a couple of gotchas with division. So the divide sign is a / here. So let's do an easy one. 3 divided by 3. Let's run the application. It's 1 because there's 1, there's 1, 3, and 3. So the result is 1. So that's how we divide numbers. However, okay, gotcha number 1 is divide by 0. We can't actually divide by 0. You can actually see now anyway, back in the day, a few years ago, if you did 3 by 0, you could run the application and you would get an error because it's not a realistic calculation. It can't work it out. So now we have a red line underneath, and when we hover over that, it says division by constant 0. So it won't actually let us run our program. But because the variable result is 0, let's just feed that into there and run the program. And again, it errors just like it should. So the first error we caught at compile time when we try and run the application, because we're using 0 here. So it's telling us we couldn't run the application. But when I give it a variable, which is result, which also equals 0, we kind of trick it in order to run the program. But we still get that error, attempted to divide by 0, which we cannot do. So that's something you should always bear in mind when working with division. You should never divide by 0. And when we talk about if statements in the future, I'll show you how you can protect your program to avoid dividing by 0. And the other gotcha with regards to division is using decimal numbers. So let's look at a decimal number example. We're going to use a double data type here, and we're just going to initialize it to 0. Now we want to let's just do an example. Let's do 3.4 divided by 5.6, which should work fine. So you can see here's the result there, which is in decimal format. However, if we do, say, 200 divided by 3, and this is not a whole integer number, it will have a decimal place on it. However, when we run the application, you can see it's actually doing some rounding here. It's rounding, I believe, down to the nearest integer, which is 66. However, if we add 0.0 onto the end of these and run the application, you can see this is the true answer here, 66.666 reoccurring, then it's rounding to 7. So this is something you should pay attention to when working with decimal numbers. C# will make an assumption, because if you have 2 numbers here, this 200 is an integer, 3 is an integer. Neither one of these are decimals. It's only the result which is a decimal. So what C# is doing is saying, oh, hey, there's an integer here. Oh, hey, there's an integer here. I'm going to give you the result as an integer. So that's a little bit annoying. So what you have to do is change at least one of these to a decimal number. And when you do that, you can see we get the true result here. So that's just something you should really bear in mind when working with division of decimal numbers. The next operator I'm going to show you is the modulus operator. So let's just put this back as an integer. Now what the modulus operator does, it gives you the remainder of a calculation. Let me do an example real quick. So the modulus is represented by a percentage mark here. So what this does, it says how many times does 3 go into 6? Well, 3 goes into 6 twice, and then there's no remainder. So the result of this will be 0 because it's the remainder of this. Again, if I do 2, 2 goes into 6 3 times perfectly. Again, there's no remainder. However, if I put 4 here, 4 goes into 6 once. However, there's a remainder of 2, so this will be the result, 2. So what modulus does, it gives you the remainder of a calculation after dividing this one into this one. So 4 goes into 6 once with a remainder of 2. So if I run the application, we get 2. And just like the very first example, 3 goes into 6 twice and there's no remainder, so the result should be 0. So modulus is quite useful when we want to know if a number goes exactly into another number. So if the result is 0, we know it's perfectly divisible by that number. So that's what modulus is, or modulo, whatever you want to call it, and it's represented by a single percentage, just like that. Now I want to talk about the order of operations when working with multiplication, addition, subtraction, all that good stuff. Let me show you an example. So I have result, which is our variable, 5 multiplied by 4 minus 2 divided by 7. And I want to add on the result of 5 plus 1. So let's have a look at this example. So if you've done a lot of mathematics in the past, then maybe you can skip over this section. It might be quite obvious to you. But C# works pretty much exactly the same as mathematics in the real world. If you've ever seen these things on Facebook or Instagram, and they say, oh, what is the answer of this? And people are giving all the wrong answers because they don't understand the order of operations here. So we have this thing in mathematics called BIDMAS or BODMAS. Let me show you that now. So BIDMAS, and some people call it BODMAS. It doesn't really matter. The only difference is the I here and the O here, but they mean the same thing. So the first thing is brackets. So if we have a calculation like this, anything inside the brackets happens first. So 5 plus 1, that happens first, which is 6. And then we can remove that, and that gets replaced by 6. The next thing that happens is the I or the O, and that's to the power of or the square root of. We don't have any of that stuff in here, so we can skip that. The next thing is division. So the division happens next, and that's 2 divided by 7. Now I'm not sure what 2 divided by 7 is. It's a decimal number, but that will happen next, so this calculation here. The next thing that happens is multiplication, so this right here. So this will get worked out next, 5 multiplied by 4, which is 20. And then any additions after that, so then the result of that will get added to 6, followed by subtraction. So the very last thing that happens is this one here. So that's the order in which this is calculated. It doesn't happen from left to right, so 5 times 4 take away 2. It always happens in the order of the symbols, just like mathematics, for example. And if we run the program, well, it can all get worked out for us. So the result is 26. So that is the order of operations, and something just to bear in mind when working with this in C#. The last thing I'm going to talk about to do with working with numbers is the power of. So like 2 to the power of 2, which is 4. If you're not very familiar with mathematics, the power of just means how many times it's multiplied by itself. So 2 to the power of 2 is the same thing as saying 2 multiplied by 2. 2 to the power of 3 basically means 2 times 2 times 2. So 2 multiplied by 2 multiplied by 2 again. So that's what the power of is. And the reason I'm showing you the power of is because the power of doesn't have a symbol like multiplication or subtraction. We have to utilize what's called the math namespace. Now let's look at that now. So if I say result, which is the variable we've defined here, and then I say math, so M-A-T-H with a capital M, and when I press the period symbol here, there's lots of different things we can do. And all these are built into our kind of C# library here, and we can use any of these. Look, there's sine, cos, tan, truncate, logarithm, all this fancy stuff. But what I'm just going to use is power, which is represented by POW. If we open brackets here, it's asking for our first number. And down here it says a double precision floating point number to be raised to a power. So let's say we want to look at 2 to the power of 2. It's asking for a double, which is a decimal. So I'm going to put 2.0 because it wants it in decimal format. And I want to raise it to the power of 2 again. End it with a semicolon. So 2 to the power of 2 is saying 2 multiplied by 2. So the answer should be 4. And you can see here the answer is 4. If we want to do 2 to the power of 3, it should be 8. And you can see where this is going. 16, 32, 64, 128. There you go. So that is how to do the power of. But not only the power of, you can actually utilize a lot of things in this math class here. All different things here. But that is an example of how to use the power of and working with numbers in C#.